Hello and welcome. And today's video will be running through the 2020 VCAA Exam 1 question 2, which was quite a poorly answered question given that it was only the second question on the exam. Question 2A was worth 1 mark and the average mark was 0.5, and question 2B was worth 2 marks and the average mark was only 1. So obviously answered quite poorly. It's a probability question, and I'll just be running through my approach and solution to this question. So the question reads: a car manufacturer is reviewing the performance of its car Model X. It is known that at any given 6-month service, the probability of Model X requiring an oil change is 17/20. The probability of Model X requiring an air filter change is 3/20, and the probability of Model X requiring both is 1/20. 2A says, state the probability that any given 6-month service Model X will require an air filter change without an oil change. So obviously quite a wordy question. Don't be afraid to read it once, twice, as many times as it needs sort of for that information to sink in. What I like to do as I'm reading through in the first or second go is to sort of state down what the important figures are. So I'm just going to use sort of shorthand here. So OC represents an oil change, and that's sort of the probability of an oil change is that first figure that we're given, which is that 17/20. And obviously, if we know the probability of an oil change, then we know the probability of not having an oil change as well, right? That's just going to be the complement. So 1 minus that, or in this case, it'd be 3/20. It's nice and straightforward. So we've got 2 key figures straight away. The next part of the question reads: the probability of Model X requiring an air filter change is 3/20. So I'm just going to label this as AFC for air filter change. We know that's going to be 3/20. Again, we'll have its complement, which will be AFC prime, and 17/20 for that figure. Great. The last piece of information that we need to extract is the probability of Model X requiring both is 1/20. So both, hopefully you guys are familiar. That's another way of saying both would be the intersection of these two events, and we know that's 1/20. So that's everything that was stated in question 2, and that's relevant to both of these parts. So question 2A, we now need to find the probability that we require an air filter change without an oil change. So what are we actually looking for, right? That's what this is asking. So we're looking for an air filter change and not an oil change. So that's this probability here. So it's the intersection between air filter change and intersecting with not an oil change. There's a couple ways to work this out. I prefer to take the Markov chain or Markov table approach, in which we list all these values in a table to sort of work out all the unknowns. Another option would be to use a Venn diagram, but for this video I'm just going to demonstrate using the Markov table. So I'm just going to put OC, oil change, not oil change. We're then going to have air filter change and not air filter change. We know for the law of total probability that everything has to add up to 1. I should have maybe drawn that line in there. So we've got something like this, and then we can put in the figures that we've extracted. So we know the total oil change was 17/20. We know not oil 3/20, air filter change 3/20, and not air filter change 17/20. And then we also were given the intersection of oil change and oil change and air filter change, right? This box here, the intersection between these two. So that's going to be 1/20. So with this, we can then compute all the other values. We know that the sum of the columns have to add up to this total value here. So 1/20 plus something equals 17/20. So obviously this will just be 16/20. And if I just go and fill in the rest, you can see quite simply the values here. And then if we circle back to what we're actually looking for, this air filter change intersecting with the not an oil change, well, that's this value here. So nice and simply will be 2 on 20, which we can simplify to 1 on 10. So that's question A there. Question B is very similar. The only difference is we're given the sort of probabilities in terms of the unknowns M and N. So it reads, the car manufacturer is developing a new model, Y. The production goals are that the probability of model Y requiring an oil change at any given 6-month service will be M over M plus N. The probability of model Y requiring an air filter change will be N over M plus N. And the probability of model Y requiring both will be 1 on M plus N, where M and N are the elements of Z plus. So the positive integers is what that's saying. Great. So determine M in terms of N in the probability of model Y requiring an air filter change without an oil change at any given 6-month service, and the probability of that is 0.05 or 1 on 20 would be the fraction there. So again, we can take a similar approach in terms of labeling this out so it's nice and sort of consistent. You can see it's really not anything too difficult. So again, we're just going to have oil change. This time it's M over M plus N. We've got its prime, or the not, probably of that not occurring would be 1 minus M over M plus N. And if we were to convert 1 as a fraction, they have the same common denominator, so that's going to be M plus N over M plus N minus M. Maybe I'll just write it out so it's clear. Minus M over M plus N. You can see that's just then N over M plus N. Do the same thing for the air filter change. Air filter change not. So see there's a bit of symmetry going on here. Great. And then the last thing it tells us is an oil change, air filter change without an oil change. So I'll write this in blue. Probability air filter change without an oil change. That's that 0.05 or 1 on 20. Great. So we've got all our figures again. Now we just go through the same process as before by putting all of that into a table. So let's do that. OC, OC not, AFC, AFC not. A little bit messy, but you guys get the idea. Great. So let's put all our figures in. We've got that 1 on 20 value. We've got OC is M on M plus N, N over N plus M. We've got the air filter change is N over M plus N, M over N plus N. Great. So I think that's all we need. I might have missed, the one value that I missed before. Sorry for that. And that was the probability of them both occurring. So air filter change and an oil change. It says that is 1 on M plus N. Great. So 1 on M plus N. Great. So you can see I already have enough information to work out M in terms of N. So if we just you can work out, this cell and this cell as well, pretty straightforward, but they're actually not required. So for good measure, let's just add them in. That you guys will see in a moment why it's not required. So this here will just be N over let's work that out quickly. M over, oh yeah, obviously, this is just m minus 1 over n plus m. And then we're going to have m minus m, so this here ends up being 1 over m plus n as well. Great. Cool. But let's just look at that equation that's circled in red. So we know from this we've got 1 on m plus n plus 1 on 20 will be equal to n over m plus n. Great. So if we take this whole expression and try to remove the denominator terms, so we sort of convert this from a fraction to a better expression. So we can multiply everything by 20 times m plus n, and be left with 20 is equal to 20 plus m plus n is equal to 20n. Rearrange in terms of m, so we have 19n minus 20 is the final answer. Great. If any of that was unclear, feel free to leave any questions that you may still have in the comment section below. If you guys have any specific questions that you want answered, feel free to reach out or let me know what the question is again in the comment section below. Feel free to follow the channel for weekly problems with in-depth solutions. Thanks.